Hello, my name is John Deriggi. I'm an application engineer for Keysight Technologies, and over the course of this short video, I'm going to show you how to automate the Keysight Technologies compliance applications for the 86100 sampling scope using Python 2.7. And so a common use model for the compliance apps is to run them manually from the front panel. There's a wide variety of compliance apps which automate standard compliant measurements and compare those against the test limits for specific standards. And a typical use model is for customers to operate the compliance app from the front panel of the instrument. However, there are cases where customers will need to automate the compliance apps in order to integrate the measurements into the test flow of a device. And so we can definitely accomplish that. On a control PC, we're able to install the N5452A Automated Test Application Remote Development Toolkit, which will communicate with the compliance app over a LAN connection. And so the installation requirements on the client PC are to have Python 2.7 installed. If you don't have Python installed already, you might want to check out the andICDesign installation from Continuum Analytics. It's a powerful installation that includes many of the modules that are required for scientific and engineering calculations. The next step is to install Python.net. We use .NET remoting with the compliance app in order to perform the automation. The next step is to make sure PyVisa installed. Note, it's not strictly required to have PyVisa installed on the control PC, on the client PC, but it's helpful and is a requirement if at some point we want to send Skippy commands to the instrument. The next step is to download and install the N5452A, and finally, we want to make sure a couple of the key DLLs are copied over to a Python folder. So I'll show you how to do all that. And so once andICDesign is installed, we can install both PyVisa and Python.net from the andICDesign command prompt. We can open the andICDesign command prompt by going to the Start, All Programs, andICDesign, and then select andICDesign command prompt. And we can install Python.net simply by typing pip install Python.net. It takes a few seconds and it's installed. We can also install PyVisa using the same method, pip install PyVisa. And so this successfully completes both of the prerequisites that are required to run the N5452A automated compliance app. We can find the N5452A on the Keysight.com website. In the main page, www.keysight.com, we just need to type in 5452A. We can open the main product page, visit technical support, select the drivers, firmware, software, and then download and install the Compliance Application Remote Programming Toolkit. The current version is 3.41. Upon completion of the installation of the development toolkit, there's a number of files that need to be copied to the C andICDesign DLL directory. If you open up the Remote Toolkit folder using the directory path shown above, you'll see there's a couple of choices for application versions. Current versions of the compliance apps are Keysight only apps, and so we would want to navigate to the Keysight only apps, select Tools, and then make sure these three files are copied to the C andICDesign DLL directory. So right now we're ready to begin automating the compliance app. Let's quickly go through a manual run of the compliance app just to take a closer look at each of the steps that we'll have to automate. The first step is to make sure that the compliance app is open. We can go to the Apps pull-down menu, and in this case I'll run the CEI compliance app. There's a number of different standards that we can perform tests to. In this case we're going to run the CEI 11 gig LR-MR. We'll have to select tests to run. We'll do all the iDiagram tests for right now. We can configure different parameters of the test, and this can all be done programmatically. And the final step is to run the tests, and you can see the compliance app takes over control of the scope. It manages all the various instrument parameters that need to be set up, including clock recovery, setting up the precision time base, making sure the pattern lock is active, and generating the eye diagram, collecting the data, and finally performing all the measurements. In this case, it makes a bit rate measurement, rise time and fall time measurement, and finally performs a mask test. It tells us the tests are done, and we can take a closer look at what the results are in the compliance app. So we'll have to automate each of these 4 or 5 steps remotely, and I'll show you how to do that. One point in the compliance app is we want to make sure that the remote automation is enabled. So we want to check the View pull-down menu, select Preferences, make sure on the Remote tab that Enable Remote Interface is checked, and we also want to make sure that the Show Remote Interface hints are active as well. And this is an easy way to find out what the required methods and properties are to set and run in order to perform the compliance app automation. And so let's walk through each of those steps in Python to set up the test, select the test, run the test, and get the test results. The very first step we have to perform is to import the various libraries that are required to automate the test app inside the Python environment, and that's what the 2 lines shown right here are doing. We're importing the Common Language Runtime, Python.net, and then adding a reference to the remote framework and importing the methods and properties from that framework. We need to give the IP address to the scope in this line, and then we're creating the object to connect to the remote development environment. The very first method that we'll use is select which test we'd like to run. And you can see there's a range of tests that can be selected. A real important point to eliminate a lot of the guesswork in setting up the tests is to take advantage of the hints that are available inside the compliance app. So we've enabled the hints, and we can go to any of the various test filters, right-click on it, and ask to see the remote interface hint. And this shows us not only the method that we'll need to set up and select that filter, but also what the range of parameters are in order to do that, to select a specific test. And in this case, I'm going to be running the CEI 11 gig LR-MR. And so let's go ahead and reset the compliance app. And so we're able to run this portion of the script, which simply starts a new project and selects the CEI 11 gig tests. Let's go on and walk through the process of actually selecting the specific test that we'd like to have the script run. To select a test, we can just use the select test method, and we'll need to identify the test numbers within the CEI 11 gig app that we want to run. Each test has a unique test ID, and we can find the test ID by using the hints that are in the compliance application. So if we expand the oscilloscope tests and expand the iMask tests, we can select the baud rate test and then scroll down in the documentation portion of the compliance app to see that the test ID is actually 37. The rise time test ID is 44, the fall time test ID is 48, and then finally the iMask test ID is 111. And so once we select those tests and run the app, we should see these tests selected. It starts a new test, and sure enough, the iMasks are selected. The iMask tests are selected once the script execution is complete. The very last 2 things that we'll need to do here is send the method to run the test, and then once the tests are complete, we'll have to get all the results back and print the results either to a text file, or in this case I'll just show them on the IPython console. And so there's a run method we can use, and then there's a series of methods that we can send to get the results back in text. So let's run the script finally, and we should be able to see all the text execute all the way through. So just as when we ran it manually from the front panel, the oscilloscope's being set up, the CDR is being locked, the precision time base is being activated, the data is being accumulated, we perform the tests, and then get the results back. And let's take a closer look at the Python script, and sure enough, you can see we have all the test results for the baud rate, the rise time, the fall time, and the iMask. And so this was a quick introductory video to show you the basic steps that are required to interface with the compliance apps using .NET remoting within Python. Hopefully it's been helpful. If you have any additional questions, please don't hesitate to contact your local Keysight support. And thanks for watching.